I get to speak next. And I get to speak about constructability. And I'll move this thing pretty quickly. I lead task group number 1. We developed the constructability blueprint, and we're going to talk about constructability. The blueprint is a reference for owners, designers, and contractors. I've been stopped. It's been out now about 6 months. It will be continuously updated, evolving. It's free. Go to the Pro website, download it. It's a great reference material. It illustrates to owners the value of early design, collaboration. It finds you can find all the elements in this presentation or whatever I share here today in the constructability blueprint. So go to the blueprint, download it, and do a word search. And it's available. What is constructability? Constructability is the effective integration of construction knowledge into the planning and design of a project to optimize construction costs, optimize the schedule, and maximize value to the owner. A lot of words, but if you're in the industry, you get it, because constructability leads to productivity gain, which is what we're here for. And as a reference, I reference a Construction Industry Institute task force. They did a study on constructability and early investment in constructability and collaboration, and they said, embrace it, because for whatever nickel or dime you spend on it, the owner gets a 10-to-1 return on that investment. Constructability allows the designer to leverage contractors' personnel, their skills, the materials, the equipment they use. It allows the design to embrace local weather or local logistics limitations. It enjoys the opportunity to have coordinated drawings, appropriate tolerances to build, reduced rework, reduce trade conflicts, and earlier completions. Boy, is that a powerful opportunity. So I got a constructability economics question for all of you. So there's the 3 buckets: material cost, labor cost, and time-dependent cost. So which cost category is over 50% of the cost of a concrete structure? And what category is optimized by design programs? Which structural element likely has the great... Oh, okay, well, let me go back for a second. Let me answer those 2. Well, material cost typically is less than 50% of the total cost of construction, and the labor cost and the time-dependent cost often is 50% or more, and cost categories that is optimized by design programs, software, are material cost. So the tools that designers are using are optimizing the smallest segment of the cost, oftentimes at the expense of time, time-dependent cost, or labor costs. What structural element is likely has the greatest cost? And so the constructability blueprint includes this graph, and it'll often show you that the greatest cost element is the floor framing. And it illustrates how the element cost will reduce over the number of reuses or number of floors, until it reaches a level that, as the project starts to elevate in size, that while the floor framing costs will level out, the columns, the wall bearing, the lateral force systems start to increase in their proportion of total cost. So as a designer, if you're designing for constructability, to get the biggest bang for your buck, make sure your floor framing cost is the most constructible, and therefore you can leverage your efforts and to get the biggest bang for your buck. Now, I'm stealing this from Kerry. I can't say I originated this. I stole this from Kerry in a previous presentation I saw him give, but I think it illustrates so incredibly well ACI codes and code constructible designs. And the ACI code is like the rules of, and Kerry probably says this better than I do, but yes, we all have to play by the rules. But the creative designer, and I think Kerry mentioned earlier that everyone follows the codes, but that doesn't mean every design is the same. And that is, in essence, designing the plays to maximize the code for best results. So, as I've heard him say, not all code compliant designs are really readily constructible. For example, member size may beat the code, yet congested reinforcement may hinder reinforcement placement, as you can see in the photo. So the message in constructability is not to be outside the code, not to be not code compliant, but to have great plays for the designer to maximize the code for productivity, for efficiency, for time, and for the best value to the owner. So, as a designer, I encourage you to weigh material costs with field labor and time. Reduce labor and time with small amounts of material by standardizing member sizes. Reduce the size changes. Reduce reinforcement congestion to improve concrete reinforcement and formwork placement. Reduce reinforcement changes in every structural member to allow the optimization of the rod buster. Increase cover to accommodate fabrication and placement tolerances. Consider expansion joints to allow critical areas to be expedited. Consider higher strength reinforcement where appropriate. Keep in mind the learning curve as illustrated in the graph above, because every time a designer changes an element, it takes them back to the beginning of the learning curve. And if you're building, for example, rebar cages, if you have one standard rebar gauge and you have a rebar crew building rebar gauges, they get pretty good after a few repetitions. But if every rebar cage has a different tie spacing or set of rods, every time you start that process, you start right back at the beginning. This is a very complex graph out of the constructability blueprint, but it really speaks an awful lot to designing for constructability. And it illustrates formwork systems, whether you have a single-use formwork system in the black, as you can see, or a gang form system or a complex form system. And the left axis is the total cost, and the bottom right axis is the number of uses. And so if you look at the graph and you think about the initial cost for, let's say, a complex formwork system, the initial cost for that first use is incredibly high. The only way that you reap the benefits of a complex formwork system is a vast number of uses, as you can see it. As you move to the right in the number of uses, it will become cost effective. And if we could have extended the line of the gang form table panel, it would obviously become more expensive than a complex formwork system. What do I mean by complex formwork system? For an example, a self-climbing wall form system with hydraulic systems in it. that has incredible high-end startup makeup cost. So this illustrates how important the number of uses are per system. Now, let's say you have a gang form system and you have somewhere between A and B uses, and there's a change design halfway into the project that makes you then have to start over with that gang form, remodify it, or change it, build a new one. Well, you may be at B uses, but as soon as that change happens, it forces you right back to the very start of 0 uses because you have to stop, reinvest, invest the time and labor. So these are illustrations of how to unleash the constructability during the design. You don't have a design with those changes that forces you back to rebuild that form. At the same way, you don't want to go back and start your learning curve all over again. So these are examples in the Constructability Blueprint of how designers can maximize the constructability in design by minimizing the number of changes. So I like this. This is a team making up a column form, a gang column form. And it's a sizable form. It's probably a 3-foot square form. And I just asked the question, what happens when the number of column sizes increases? And so if a floor has 50 columns and you got 20 different sizes, you've got to go through the learning curve of building each one of those versus being able to build a number of the same size. And then where do you store them on site? And how often do you get a chance to reuse that size form? What happens if the column form height changes? If the height is reduced, okay, it's easy. Cut the lumber off, take a bracket off. But what if it's higher? And a higher column form modifies the hydraulic pressure in that column form, may modify the clamp spacing. And it's very difficult to extend that column form up. What happens if the dimensions change in the field? And even if you reduce the column size, it's easy to pack out one size of the column form. But let's say you have a 36 by 36 inch column, and the design as you go up reduces it to 36 by 30 column. To save some material. Very efficient, totally understand it, happens. You can take a column form, pack out one size by 6 inches. Now, think about in the field with that carpenter that has to set that column form. And he's got a 36 by 36 inch form on the outside, but inside that form, he's got a 30 by 36. What is the probability of error that he orientates setting that column form 90%? Off what it should be. So it just, and the side effects of the constructability problem associated with that. Just an illustration of how important it is to maintain some of those member sizes. And again, back to the learning curve process, what happens when these changes happen during construction? You drop right back to that 0 use stage of the learning curve, and you start all over again. And every concrete contractor that has ever gone through this process finds it absolutely impossible to get compensated for those changes and the learning curve impact and the reusability of that form. So I'm not trying to be excessive here. What I'm trying to do is show you the kind of information that's within the Constructability Blueprint that every owner, every designer has access to. Every contractor can use it as a rationale for their requests for compensation when changes happen. But more importantly, what we really want to do is make that design as constructible and a collaborative effort to minimize these kind of costs, to deliver clients the greatest value of their concrete structure by a collaborative, constructible design from the get-go. I'm going to skip this graph because I could probably sit here and talk about it for 20 minutes because it tells so much about what you've heard earlier today as comparing design bid build versus a collaborative design. But and Pro did not develop this graph. This was and in the document it's referenced the creator of it, but go to the constructability, get this graph because it quite frankly illustrates the value of a collaborative design and the hurdles of a design bid build auction, as I've heard mentioned today. Again, I'm stealing this from Kerry. I saw it in one of his previous presentations, but it really rang home to me and as a contract and back in my contractor days of how important or how well you get the message. I don't need to describe it. Okay, there's the reference. The book was written by Bryson and Yetman, and the book is called The Owner's Dilemma. Driving Success and Innovation in the Design and Construction Industry. It's been out for a number of years. It's got a fabulous message, but quite frankly, the dilemma that owners face is what you've heard earlier today, and the belief that that auction, that low bid price auction, is how they maximize value, and the dilemma is it really doesn't. So, in the sake of time, I'm going to slip through these pretty quickly. You can read them for yourself, but here's some constructability recommendations, and one of the frustrations I've heard from designers is every contractor I talk to has a different constructability recommendation. And they absolutely get frustrated by thinking we cannot become a master of constructability because every contractor have a different perspective, and they do because their perspective is based upon their personnel, their skills, their experience, their equipment, their history. So every contractor may look at a design differently, and that's the reason why you need them part of the collaborative design so that you can leverage their skills, their experience, their equipment, their local presence. This is a graph that illustrates so much of what has said today. And again, all of this is in the constructability blueprint, and it's really busy. So I won't spend too much time out of it, but in essence, it says that the ability to impact cost is lowers as the project phase proceeds. And if you can be part of a collaborative design and impact the decisions earlier, you can increase the owner value. And if you don't, the design bid build process is quite frankly a lost value for the owner. I had to add this comment because this is from FMI, and I'm sure everybody here has heard of the consulting firm FMI, and they speak quite often. But this was a post from Scott Kipling, and I'll let you read the highlighted portion itself. But in essence, it says if we were to establish the industry today, we'd do it completely different. And I think Rich Farr and I think Chris and others that run our task groups that lead them are really trying to change how our industry presents itself to eliminate the waste and half-baked, unconstructable designs, as he referred to. We really need to get this fellow to be part of Pro and be part of our message because he gets it. He truly gets it. So who's focused on constructability? And quite frankly, I'm going to tell you we're all focused. There's the ACI's focused on it. They have the certificate program for concrete constructability. You've heard it mentioned earlier today. If you are an ACI member, it's free. Do you get additional educational credits for working through it? Absolutely. So I promote it. I think it's a great start, particularly for young designers. Of course, you've heard us all mention the Constructability Blueprint. It's a resource that's out there. I will tell you, ACI has a committee 134 that's focused on constructability. American Society of Concrete Contractors have a constructability committee. And we keep referring to this McKinsey Global Institute, but two of their recommendations, obviously, is to improve the constructability of design and embrace innovation, which you've heard of today. So for those reasons, Pro are focused on those barriers of productivity. So there's many in the industry focused on constructability. Pro has an industry outreach, and I'm not going to go through any details, but I'm going to promote the World of Concrete. In January is going to hold an engineering designing for constructability engineering symposium. It's a full day event. They have a full day list of speakers. There's a couple individuals here today. I hate to promote the World of Concrete and their educational materials and the fact that they charge for it, but at the same time, I want to tell you that it is pro-centric, it's constructability-centric. It's if anything that promotes the collaboration, the coordination, the communication between contractors and designers and owners, I think is a great thing. So where do we start to improve concrete constructability? And I know my time's running out, so we need to educate owners of the missed value opportunity of what I will call the auction approach. We need to embrace the designer's role in concrete constructability and productivity. We need to leverage trade contractors and designers' knowledge and to build ethical networks to collaborate. We need designers to become field focused. I encourage designers to put their boots and eyes and ears to the ground on the job sites. We need to learn constructability design principles. And quite frankly, as a designer and as a contractor, I've often seen concrete constructible issues as really an opportunity to learn, to grow, to improve our trade, our skills. With that, and I know I went through this incredibly fast, largely because it's all available to you. Just download it off the Pro website, but the Pro members as listed here, I want to thank them because they're the ones that are supporting this effort to enhance and improve our industry, to create not only good concrete structures, but to elevate the value that concrete can deliver to owners and unleash the technology and the know-how and the systems that we all use and live by. The chapter members, Pro has opened the door for a chapter membership to ACI. The Carolina chapter opened that door. They encouraged it. They asked for it. I see Cecil with us today that led that effort. I believe there are a couple other ACI chapters that have initiated conversation and want to become Pro members to expand the flow of Pro footprint and create a conduit of dialogue and information and educational material. In addition to that, in the bottom right, when I put this slide together, ASCC was our first affiliated, I shouldn't say affiliated, but they're allied organization with Pro. CRSI has jumped on board, PTI has jumped on board, NRMCA has jumped on board. I expect within a week or 10 days, ACA will jump on board, and I also expect the American Shotcrete Association to become an allied organization for Pro. All of these organizations are absolutely energized and excited about the impact that Pro wants to make to improve the culture, the working environment, the risk allocation, the constructability of concrete structures, because we all succeed as a whole and as a unit if we can improve and increase the value of concrete to owners.